Hi, it's Greg. First of all, no prizes for guessing what this is. The Pocket Money Kit 9 four-way traffic lights kit from Merg. This one's built significantly different from what you build if you build a kit, purely because I build them so that I can easily demonstrate what they do. The standard kit has links that you put on the board to say I want you to run in this mode. But the ones I build for demonstration have jumpers on them as far as I can, so that I can change the jumpers and show people what they do. This one's running the version 2 code, which supports continental or UK light sequences, and that's controlled by the second blue jumper down from the top. Currently it's set to do a UK sequence. The three jumpers below that are to set the speed at which the lights cycle around. With three jumpers on, it runs at the fastest rate possible, which is useful for testing, but really not what you would use for setting up on a layout. The code that is here is actually a development code. It goes a step beyond what the standard PMP9 does. The top blue jumper enables an extra function that I'll show you a bit later on. Basically the code that's on here is a release candidate, and I'm having some discussions with people at the moment about what should or shouldn't be in the release, and some other options that are in here. For one, the outputs, as you can see down here, normally on the PMP9 there's a set of resistors on the board after the ULN 2003 driver, and the resistor that's there is put in front of a whole lot of LEDs. And what we'll talk about in this video is why I chose to take those resistors out and how it benefits you. The other thing is, on the standard kit, all of the outputs come straight across from the PIC through the ULN and straight out through the resistors with all the pins lining up. Here you can just see that I've reordered the outputs. The links that come out of the PIC move along, and you can only just make out a color code down here. So by reordering the outputs, what I get is, first one out is 12 volts, next one out is red, then amber, then green, then the second bank of outputs for the traffic lights, same sequence, 12, red, yellow, green. Okay, so other changes on this demonstration board. There's an input capacitor, there's a reverse polarity protection diode that I had to use a surface mount one and put underneath the board. There's a small power LED indicating there's power on the board, though it's kind of hard to see in the current light conditions. There you go. I've used connectors rather than just having wires coming off this, as you'll see now, as to what the how the change in the outputs gives me a different function. So what I've got here is a little test board that I've made up that I can slip straight over those pins, and I get two banks of red, yellow, green lights. So I'll put it on the right way around, and you can see that it's cycling through the lights, and what's more, you can see it's cycling through the UK sequence because we get a yellow before the green. If I take the jumper off here that changes UK to continental, you'll see that it'll start going red-green instead of red-yellow-green. One of the changes I made to the code to assist in demonstration is that it more frequently checks to see whether any of the jumpers have changed. Every time it gets back to a red-red sequence, it's checking to see whether I've changed the speed and checking the mode for the output. I'll put this back on. Now, I said there were some advantages to reordering the outputs. Obviously, they're in the same order, but what's beside these is, for purposes of this demonstration, I'll call it a mast board, and it has 4 wires in the same order. That for this one I'm going to put it on this bank here. It's a bit fiddly because they're all individual connectors at the moment. Go on. I'll try again. Okay. Now you can see that this board is following this board. What I forgot to say is on the test board here, there's LEDs and the resistors for those LEDs. There's a set of connectors here that allow me to take the output straight off the board, straight out over the wires onto the additional board. And on this board I've got 2 connectors basically. So if I take this connector off, you can see that there's 2 green, 2 yellow, 2 red and 2 white. And I basically I cut those off the strips. I put jumpers on top of them to hold them in position, and then I soldered them onto the board with the jumpers holding the spacing correct for me. There's another one over here, and I've got 2 choices at this stage. I can either connect it to the missing bank here, or I could connect it to this bank over here, and I'd have 2 operating on this sequence and just the 1 operating on this sequence. And that allows me to do things like in Queensland sometimes we have 1 traffic light on the left hand side and another one on the right, so I could put 2 joined together to simulate that. Sometimes we have 1 overhead, so you could join another one, again daisy chained, and have all 3 lights facing one direction. T-junctions are easy to do, 1 on one side, 2 on the other. It makes it quite simple. In terms of using it on your real model railway layout, when you buy a set of traffic lights or signals even for your model railway, they come with LEDs already in them, and those LEDs may need resistors that are totally different to the ones that you have built on the board if you build the board as standard in the current documentation. By taking the resistors off the board and putting them out on external boards, imagine, if you will, that this board here is underneath the layout, and 4 wires coming down from the lamp from the mast on the board. What I can do then is put the appropriate resistors to get the red, the green and the yellow on that mast to look correct on my layout, and have the fly leads joining in. So I think that taking the resistors off the board is a good thing. It makes connecting test stuff easy. It makes connecting production stuff easy. I think that reordering the outputs is good because I get the same connection order on each and every mast. I'll just plug that one in so it's actually doing something. Whether or not people build themselves a little test board to do what I did on this one, it matters not. It just for my purposes, it demonstrates the extensibility of this approach. People may not choose, or may choose not to put the straight 0.1 inch headers on there. They may choose to put Molex connectors on there, or whatever they like. Obviously you can't put big stuff in there because it's only a small board, but I wish this was easier at the moment. It's the problem of putting development stuff into production. I should have just superglued these headers together. Okay, I think we're good. Okay, so yeah, that's about it. What else is there to say? Yes, there's a 7805 regulator on this instead of the 7805L. That's the bigger regulator here. I like them because they're larger. They have a larger current capacity, which is not required for this board, but it does have a big metal tab on the back of it that keeps the regulator cool as a cucumber. Anything else? There is one other thing. The extra jumper I added. If I connect this jumper, what you'll see, again, it's checked when the lights go back to red. Right, all the LEDs are on. So if I had just assembled this board and I wanted to see that all the LEDs are going, or I'd added an extra mast into the into the mast I'm using on my layout. I may want to see that all the LEDs are going fine. So by adding an extra jumper in there, it means I can look at them all in one go. Rather than without it, I'd have to go around and watch every single mast to see that it's working and wait for the sequence to go through. So I think it's a useful addition for setting up and for testing, and it takes very little to do. Other things I'm considering for this one, there's still another input. I could make that so that if that input is switched low, that probably the lowest speed jumper here is reused as an input. And what I would do is to say, right, if there's a set of traffic lights that also guard a railway crossing, then I want the traffic lights to stop on red when the crossing starts flashing. And that would stop you from having the anomaly that the lights are saying green and the crossing continues to say red, or the lights are cycling through and the crossing has stayed red. So they're the thoughts. That's what it does. Lots of ums and ahs, but you can tell that I'm not going through a script to say, hey, isn't this wonderful? I'm telling you how it is and what it does. And if you built this for yourself, it wouldn't be as squashed as this is. It's really squashed so I can fit the jumpers and the extra components that I've put in there. I'm sure that I can reorganise this board to allow to have Molex connectors on this end if you're not using jumpers down there. Some of the inputs have already got weak pull-up enabled inside the PIC, so I could get rid of some of the resistors on the board as it is. And I think that would be kind of helpful because for mine I'd like to see a reverse polarity protection diode and an input capacitor on the board, as I've done in this demo one. That's it, guys. I'll start uploading this video, and because of my limited bandwidth here, that's likely to take a few hours. Thanks, guys. I hope that was informative and useful. Last thing to say, this module is one of about 10 pocket money projects that are sitting on a demonstration board we used at the Brisbane Model Train Show last weekend. Really well received. The story about you can build these yourself for a lot less than buying commercial stuff, and we can help you do it, was extremely well received. The fact that not a module on here cost more than about $6 is quite a compelling story, particularly when you get to the Servo 4s as well, and you compare those to the offerings from A&E and Pico. So yeah, we had a great day at the train show. Thanks everybody. Thanks everybody involved in the train show. I'm not getting any feedback on these videos, whether anyone thinks they're useful, whether people think I really should scrub them up before I post them. I'm trying to just be informative and get them out there. Production quality stuff, there's a bit of blue cardboard behind this stuff. I'm using an iPad and a headset and a microphone on that to produce it, not editing them afterwards. But I don't really want to spend my life video editing, and if they're good enough, they're good enough. So, but let me know what you think. Doing this without any feedback, it sort of makes you wonder whether it's worthwhile for anyone. Thanks, guys.